Okay, I should be live. Hello, everyone. Welcome back to the stream. This evening, I have only day 11 to do, and I don't think I'll be doing a lot of work on the compiler just because I'm a bit tired this evening. So I think I'm just going to do day 11. We'll see how that goes. As for today, it looks like a graph problem, so probably some kind of path finding problem. It looks easy, but as usual, I expect part two to be where the difficulty actually is. And I have some ideas for interesting things to showcase, at least in part one. We'll see what part two is about. So, yeah, let's go. So let's start by doing some setup, I suppose. We're already at the second to last day. Okay, so that's our example. Now, here's the thing I want to do that's going to be, I think, interesting to do. I want to use laziness to represent this graph that we have here as an actual graph where we don't have like indirection. We have actual pointers from one node to the next, despite the fact that, like, immutable things, so they have to all be created at the same time. And when I exploit laziness for this. So what I want to do will be a graph, and the graph is going to be a collection of nodes, which is going to be a hash map from name to node, and name is just going to be a string. And we're going to have our root, I suppose, which is going to be a node. And we're going to have our exit, which is going to be a node as well. What is a name? That's just a string. I can already create some constants. The root name and the exit name are strings. And the root name is u. And the exit name is out. Now, what is a name? What is a node? Here's where the magic is going to be. A node is going to be something that contains its own name, which is going to be a string, and it's going to contain, is it data in, data out? Are we trying to look at the flow of data? Yep. So data in the parents, that's going to be a list of lazy nodes. I don't know if this notation will work or if I will need to have to use this notation. Probably this one. Although I'm going to try this one. We'll see if that works. And data out, which is going to be the list of the nodes from this one. So the problem is this is a, like, the parent will have a pointer to its child node. The child will have a pointer back to the parent. So this is a fully circular definition, which means we're going to have to use some tricks there. One thing we're going to have to do is we can't use the naive instance of show for this. Because if we try, this show is going to go recursively through all of the other nodes and, never finish. The thing is, if there are no cycles in this graph, then it should be possible to represent all of the data out. But I don't want to make the assumption yet that there is no cycle in the graph. So for now, let's do as if there could be actual cycles. So if I have a name, in, and out, how do I want to represent a node for debugging purposes? Something like plus intercalate of map node name of ins. Actually, I'm going to do it as a concat just so that it's a bit more readable. Nope. There we go. And then finally, there we go. So that is going to be how we represent the nodes. Now, the big thing is going to be how do we, and I'm just going to remove the input thing, and I think I'm just going to give the graph as argument. Now, the big thing is going to be how do we parse this? And the trick is going to be we create a hash map from name to the pointer, and then we create all of them by referencing the expression within the hash map, so they all reference the same pointers, and that's going to be the trick. So, we're going to need to know, we're going to need to create a hash map from the node name. Hello, how are you? I'm doing some, you remember the circular programming stuff from yesterday? I'm going to do some tricks with laziness that you might enjoy. Because here I am passing the input, which is a graph. And I suspect that there cannot be a cycle in this graph, but I'm not gonna make this assumption for you just yet. So for now, the part one is we have this graph here, and we want to find the number of paths that go from the node labeled U here to the node labeled out. So this is purely a traversal of the graph and counting the number of paths, nothing too complicated. But I am afraid of what part two is going to be about. And I'm also using this as a excuse to do some funky laziness things, such as having a graph in which each node contains a pointer to its parent and a pointer to its children node, without any direction, an actual pointer to them, and therefore making it an infinite structure. It is a directed graph, yes, but having a pointer to the parent will be useful for some things, I think, including for part one. But it could be, I don't think there are cycles, at least there don't seem to be any cycle in this example, as far as I can tell, but I don't want to make, oh, hello everyone. I don't want to make necessarily the assumption that there is no cycles in the real input, which is why I'm trying to do this very lazy thing. So first, we are going to have, before we can create the actual graph that has all of the pointer magic, we need to first parse the input. So let's start with that. Again, I'm going to be using parsec because that's just extremely convenient. The only thing is I might want to cheat and use a state monad to keep track of what node is the U pointing to. That might be the easiest. Maybe not, actually. Maybe I don't need to do that. So I will create, I think what I need to do is create a list of edges from which I can then create the graph. So this will be some kind of post-processing after doing this thing. We're going to create a graph at the end. So now how do we parse one given node? Well, the format is fairly simple. This is going to be first the node name, which is going to be, I'm just going to call the function name, I suppose. Then we're going to have a symbol that we ignore, which is this, and it's going to skip spaces for us. And then we're going to have many1, or rather we're going to have the sub nodes, which is going to be name separated by space. Let me just have a quick look in my library of Advent of Code functions. Do I have an alias for spaces per role? It's already there. Perfect. So I can just do spaces. There we go. So that is going to give us a list, the name and the list of nodes. The only thing is I probably want to check whether I will have the U name, because the one that is called U is special. It's not that AAA points to U, it's that U points to AAA. So it's a bit of a special case. So I would probably want to try to see if U is part of it. Although I suppose I could do a kind of like having this name thing written something different in the case. Nah, it's gonna be too complicated to do it here. Let's do it here. So I want to test if the start name, the root name, is part of the subnode, and do two different things, basically. We'll see what we do when we get there. In the meantime, we can decide how to pass a name. A name is just many1 lower, and I might even already have an alias for this because this is a common thing. Identifier, there we go. So I can replace here name with identifier. So that should be parsing it. That should be already done with parsing. The only thing is at the end of this, what will we return? Well, it's going to be in the different branches, but in the case where we don't have the starting node in the list and we therefore don't need to remove it, our output is going to be a list of edges, and therefore it's going to be for each of the sub nodes. Since this is a directed graph, what are we going to do? You're going to map a tuple creation function, which is putting the name n at the beginning of it. So we are creating a tuple of from the name to the subnode, and we have now a list of the things. So now at the end of this post-process function will be getting a list of the thing we created for each line, which is a list. So we then do a concat here. And now we're going to have this post-process function that doesn't exist yet, will be taking as argument a list of all of the edges that we have found. There's something that was wrong somewhere in this file. And I know because the sum of the alignment doesn't work. Okay, so here, what do we do in the case where we found the U in the thing? We're going to have to create a special edge. I guess I could do it pure here directly. Pure here. So I don't have to do it here. So we're going to have to add a special edge, which is going to be from the root name to this name n at the beginning of the list of the edges that we want to create. And the edges that we're going to want to create are going to be the same, except we're going to want to delete. Let me just check. Is it delete? It is delete. So delete root name from the subnode. And I'm going to need data list qualified as L. I'm going to need data hash map qualified as M. I probably don't need parsec since I'm only using the functions I have as part of my small. So it is a special name in the exercise. Basically, the node label U is not an actual node. It is, I think it's a post-it put on U or something like this, according to the story. An elf hastily attaches a label which just says U. So you start, basically, that device that is labeled with the U is the root of the graph. And I'm choosing to not represent this as being like, this is the root node. I'm creating a fake root node named U that points to this one. So this fake node I'm creating will be the one that contains. So this is not a real node. So this is an exception in the format, basically. In the same way that out, which is the exit of the data flow, there is no node label out in it. It's just a special name for it. The exercise uses those two special names for this. But I'm going to represent out as an actual node in the graph and U as an actual node in the graph. Okay, so next, what I will want to do is I have, if this works, and in fact it should be all, this is just path with node, I can write my post-process function that will take a list of all of the edges and create this graph here out of it, which means we are going to need a hash map from name to node, which is going to be what do you mean the line below says U? Because here, this is the flow. Like this syntax means there is a edge from A to H. There's an edge from H to C. There's an edge from C to F, and so on. But there is no edge from A to U. U is not a node in the graph. It's just a label to indicate that this is the start of the graph as far as this exercise is concerned. And I'm choosing to represent it differently. I'm choosing to represent it as if there was an additional line. Instead of having this, I'm choosing to represent it as if there was... Oh, wait, you're right. There's a line that says U. Huh, you're right. You're absolutely correct. I was convinced that there wasn't. So, that means I can discard what I've just done. You're right. Thank you for catching this. So it means I don't have to worry about this. That's convenient. I don't think there's one for out anyway, but that's fine. Yeah, good catch. Thank you for that. So it means I don't need to do this if. That's convenient. Since U will be in the graph already, and that's the start, I can just do this. Now, I could also... I will need to know the list of the nodes. And the list of the nodes I could gather... I am tempted to, instead of doing this, I'm going to return a tuple, which is going to be the name of the node I'm processing, and then the children. This is making the assumption that each node will appear only once in the input, which I think is a somewhat safe assumption, at least I hope. I suppose then it's not a root. It's a start rather than an exit. And therefore in my graph, I'm going to rename this from... So I'm going to prefix this just to avoid polluting the scope. Okay. So next, what do we do here? So I have this list of tuple of things. So I'm going to unzip it. And now here, what this gets is a list of nodes, well, names, I suppose, and then a list of edges that needs to be concatenated. So now I have my list of names. I can create my graph by doing, and I'm gonna also add something to it. I need to make sure that I remember to add the exit name out, because I want to create a node for it, even though it doesn't exist in this list of names. Now, what do I do here? I'm gonna create a hash map, which is gonna be this hash map here, from name to node. And here I could actually use name since I've used that. So what is this hash map going to be? This graph map. This is going to be a from list of, and I'm going to use here the do block in the list monad for each node in the list of names. What do? We are gonna need to figure out the edges in and edges out from the list of edges, basically. We can probably try to do that in one traversal. So it's gonna be edges in, edges out. It's gonna be find edges for that node in the list of edges. Well, names plus out as mentioned. And what are we going to do here? We are going to create a node. Which is going to be node with that node name. In fact, I should probably say name here for readability. Name here. We are creating a tuple because we're creating a hash map. Name. And here we need the node of the parents and the children. And this is going to be, and this is where it gets magic. We're going to do, for each of the edges in, we are going to do a lookup in the graph map. I'm going to rewrite this, I think. I'm going to rewrite this as a list comprehension, I think. This is going to be lookup E in the, well, I'm even going to use this operator. For each E in the edges in, and the same thing for the edges out. So here we are doing some laziness magic again, where the definition of the graph map makes use of the name of the pointer in the definition, which works only if we have laziness, which is why I've put some laziness indication here on the values of the list. And this should create a thing where all of the pointers are used by looking in the map, and the map contains only one node each, so we have all the pointers tied together, and we have a graph. That should be basically it. And at the end of this, we will return a graph that is made of the graph map and of looking for the start name and looking for the exit name in our hash map. Okay? Now we're missing only one thing, and I'm going to make it a separate function, I think, for convenience, which is the find edges, that given a name and a list of name and name, so the list of edges, will give me a tuple, a list of name the edges in, and the list of name the edges out. Find edges, I'm going to write this as a recursion. This is going to be given some name n, or name, let's name it. It's going to be a fold using a function called go that we're going to define. Our starting accumulator is going to be two empty lists, a tuple of two empty lists, because there have no edge has been found yet, and we are iterating over that second argument, the list. What do we do in go or step? I like to name them step and not directly recursive. Step will take our accumulator, which is edges in, edges out, and we'll see one edge with two nodes, node from node 2. And what do we do here if node from equals the name, I'm gonna assume, since I assume there's no cycle in the graph, I suppose I could handle actual like node that point to themselves. It's doable. I'm gonna assume there isn't the case. I don't think there's the need to handle that, but it's technically doable to handle. In this case, if the node from is the same as the name here that we have given as an argument, that means this is an edge that is going from this thing. So we change our accumulator. The edges in remain the same, but we add this edge. Well, no, I don't need to do that. I just need to add the node 2 in the list of edges out. If the node 2 is the same as the name, this is an edge in. So node from goes into the edges in. And edges out here. And otherwise, if it's neither case, oh, I have the wrong syntax. This is an equal sign here. Otherwise, we do not add the current edge to the list because it is irrelevant. Therefore, our accumulator remains unchanged. Okay? So that should be everything. That should be everything. We have an instance of show for everything, except for graph. Let's make one. It's going to be unreadable, but that's fine. Let's try this. Let's comment this all out. And its fact, let's do a traverse print of the elements of the graph map. How is it called? G nodes of the test input. If this works, there's another tangent I want to go on before we actually solve the problem of day one. And this is going to be a problem of representation. Let's try to compile. What's wrong? Pass error. Do I have... Yes, I forgot to close the tuple here. Data hash map strict. Why aren't you... Ah, there we go. So the laziness here has to be at this level. I hope this is going to work still. There's no longer a name. This is identifier now. Sep by comes from parsec that I have removed. So I'm going to need a text parsec back in my list of imports. Okay. Didn't I use anything from the list? Interesting. I thought I had. Oh. Thank you, warning, for catching this. Read input is never used. Okay. I'm running the wrong day, I think. Oh, I'm just doing a build. So let's run 11. Oh, I did not download the input for day 11. Which looks like this. Okay. It's pretty big. Okay. So as you can see, it seems to have worked. Except, so U has no parent. There's no point pointing to there's nothing pointing to U. And it points to C and B. That looks correct. C, this one. This representation is not great because the name is in the middle. Maybe I should represent it differently. How do I want to represent a node in the graph. Perhaps let's start with the actual name then. And then let's do... Let's just do in out without the arrows, perhaps. Something like that. Maybe it's gonna be easier to read. Okay, except a space would be good. Okay, so F has two arrows coming in, two edges coming in. It's gonna be H and C. H is going to F, C is going to F. Okay, that looks better. U has nothing coming in, A has nothing coming out. Oh, out has an arrow pointing to out. I think that is a mistake. Wait, no. I've labeled this as out, but this is just I has an arrow pointing to the node labeled out, and out has no arrow going out. Yeah, we're good. But interestingly, again, the whole point of this was this is a... There is no indirection. Each node contains directly a pointer to its node's parent and node's out, and this is all tied together by laziness because the nodes are created referencing the hash map, which is created at the same time. If I remove the laziness annotations, if I try to make this so that here the node is fully evaluated when the thing is evaluated, then this will never terminate because it's going to try to evaluate F, it's going to need to evaluate H. To evaluate H, it's going to need to evaluate F, and it's just going to be an infinite loop. This is never actually going to finish. Oh, it does. Fascinating. Wait, I have strict data enabled. How does that work? Oh, I guess it's just that actually... No, it's fine. It's fine because there is no... It's fine because there's no cycle, there's no value that depends on itself directly. I was expecting this not to work. I'll take it. It's better that way. I was convinced this wouldn't work. Interesting. I guess it wouldn't work if I were trying to define... No, the fact that this works here... Huh. Because the thing is, I have... Oh, this is because it's a list, and list is not impacted by strict data. There we go. I have an extension enabled called strict data that makes all of those fields strict. So the node, the list is strict, but its content is not, because the list type is not impacted by this. If I had, however, just an actual node, then this thing of removing the laziness annotation would actually break this. Well, in this case, I don't need to bother with the laziness annotation, I suppose. So now we have our graph, and I want to do one small other thing. I want to use a library that I have made, a package I maintain on Hackage. I want to add a dependency on this library, since it's not in since it's not known by Stackage, I'm gonna have to put it here as well. Which is a library that allows me to export dot graphs, GraphViz graphs in dot format. And what I'm going to do is I'm going to try to render an SVG of our graph for visualization. So let's do a render function that, given some kind of some graph, will give me whatever the output of my library is, which is probably going to be a string or a byte string or something like this, probably text. Dot There we go. That's the one. Rendering the graph. This gives me a builder. And what is this builder? It is a text builder. Okay. So I'm going to need text builder in my dependencies. Okay. And text builder, I assume, is going to give me some text. Yep, perfect. So what are we going to do here? We're going to need to run the monad of that library of mine, and we're going to want to make that a directed graph. And I just want, I think, a dgraph t, maybe a strict one. Yeah, I don't think I need to do anything with the top level thing, so it's going to be a strict dgraph t, and we're going to do that as a monadic thing. And at the end, I will probably want to have a state monad under... No, okay, it depends on whether there are cycles in the graph or not. If there are not, I don't need to use a state monad to keep track of the... Because if there is no cycles, then... no, even then, I need to be careful. I could be visiting the same node twice. Okay, so I'm going to need a state monad. So I'm going to do an eval state, and my state is going to be a hash map of, for a given node name, the name for it in the graph. So it's just going to be an empty map at first. And that's going to give me, at the end, the text builder. And how do I run a text builder? Run. Perfect. I'm just going to import data text builder. Or is it just text builder? It's just text builder, no data. Qualified as TV. And I'm probably gonna need text for the output. If you've done anything with Haskell, you know that the string type is extremely controversial because string is just a list, a single linked list of characters. Text is the one module that you really want to use instead. It has a better API. It is better in terms of performance. If you want to deal with strings, text is the right type, 90% of the time. So we are gonna do this eval thing, and at the end we are gonna do a tb run, which will transform the text builder into some actual text. Okay. And what do we do? I suppose we're just gonna start by visiting the start node. So what do we do when we visit a node? So we're gonna have its name, the parents that we're gonna ignore, and the children. What we're gonna do is we're gonna look at whether that node has already been seen or not, I suppose. And if it has, we have nothing to do, basically. So let's do a lift of get s with a lookup of the name. And now we can do a case of that. If we get just a node ID, we can return the node ID. That means we've already encountered this node while traversing our graph. We don't need to do anything else, and we can signal to the parent what the value was. Um, just one thing about this. Strict dgraph. Let me just check one thing from my library. Okay, it ignores the return value. That's perfect. That's what I needed. So we return the node ID to the parent, but in the case where it's nothing, that is the case we are interested in. We don't have an entry for this node in the graph yet, so we create it. So the node ID is going to be node. I might just text qualified as TD. Maybe not qualified, just TD. Let's make it qualified. Let's be explicit. So this is here. This is this TD, and here this is the TD node. And the node takes an argument, which is, how do we create things? Is it just the text? It is the text. And I have here a string, which is the name, and I just need to transform that into text with back the name. So now I have my node ID. So now I can traverse with Go all of the children. So I can then get the children IDs by doing, or in fact, I don't need to do that. I can just do for each child in the children. Oh, first I need to put this in the state so that if there is a cycle, we don't actually reprocess this thing. So I need to modify my state by doing an insert of that node ID for my name. And for each child in the graph, what do? We get the ID of the child by going recursively. I'm just going to do this for readability. Go visit. I'm going to call it visit, I suppose. It's a better name than go. Visit that node, get the ID back, and we can add an edge from this node ID to the child ID in the graph. I have a cute operator for this. I have this operator, but I think here edge is a bit more explicit. And there's one more thing I'm gonna do when name equals start name. Its fill color equals light green. Let's have a quick look at actually not the CSV colors. There we go. That's what I was looking for. What color do we want the start node to be? Let's go for a nice green, I suppose. Pale green, perfect. And the name of the exit, if the name is the exit name, let's say its fill color is, and let's do some kind of purple, pink, perfect. Or plum, even better. There we go. That should be everything we need. And at the end here, of course, we need to return the node ID that we have created. Okay, and now that should be enough to render a graph. So we can try. Here, I'm going to need text IO. So that's the one. So I will want a write file, I think. Yeah, That's going to be enough. Here, let's do a write file of test input SVG. Well, no, it's not SVG yet. This is the dot file of a render of the test input. Okay, and it has to install a few dependencies, including my library. There's a few things I'm happy about with this library. It's very simple. One thing I'm happy about is the it thing, which is basically this points to the latest thing that has been created. So since here we've just created a node, it is a lens to the attributes of the nodes we have just created. Which is modeled after the GHCI it, or if I do equals, I don't know if I can do this like 42 here, it is 42. I don't actually, if I do a let a equals 2, it is still the last result, not the last expression. Okay. Something did not compile. My own library did not compile. That is humiliating. Is it because I'm using a different version of the compiler and I have not tested on with this version of the compiler? This might be a problem like this. Huh. Well, there is a way to fix this, which is to, instead of using the package version, let's use the one that is local. There is a way to do that. I never just remember what the syntax is. I never remember what the syntax for this is. This will be putting here in extra depths. Okay, so I can just do that, and let's use the local version then, which I will need to then update with to use the current version of GHC, I suppose. So this will be yeah, I see the error. Indeed, but this is now easy to fix. I can just let's open a new Emacs briefly. So what? I thought my test suite was actually testing. I'm surprised by this. Because if I remember correctly, I am building against workflows. I test on 9.8, 9.10, 9.12. Huh. Or is it that this is a warning that I have warnings enabled in this project or something like this? Weird. Weird, weird. But I can replicate the bug, so let's try this. What version of GHC am I using in this project? I don't remember what the command for stack here is. Just stack ns or something? That's gonna be for the... It's just the tools, that's not what I want. I know that I'm using 2243. Which is this one. This is, oh, this is GHC 6.6. Aha, this might be the problem. This is such an old version of GHC that my test suite from my library did not test this old version. Okay. And in fact, yes, this is a long-term support version of Stackage that dates this a year old at this point. So maybe what I should do is, instead of fixing my library, which doesn't need fixing, is upgrade the Advent of Code project to a more recent version. So let's do that. Let's say 2423. Oops. Let's close this thing. This may take a while. Except... What are you unhappy about? Ah. Can I just... How do I do this? Because I don't care about this. What's the documentation? What's the shape of the thing? Allow newer. Let's try this. If I put this as a property of this, allow newer true, are you gonna be happy about this? You're not. Okay, ignoring this thing. Perfect. And now I think this resolver is the one I'm using for the other project, so it shouldn't need to recompile the entire world. But now my library should compile. This is purely okay. There's no way to add this at the package level, just at the configuration level. That's fine. Okay, so now we wait. Okay. Why is Aizen a dependency of this? Maybe a dependency of a dependency, I suppose. Ah, now we're done. We're compiling some of the dependencies from yesterday, like SBV. Okay, GraphWiz seems to have compiled. That's good. We still haven't tried to compile this, actually. We'll see. We'll have to see if it works. SBV is slow. It compiles all of the examples. Okay. Incredible. Come on. What's the error this time? Is it because the dependency has changed? Come on. Why is it so complicated? This is not what this was supposed to be about. Because I am using Text Builder. Oh, indeed, Text Builder has a new version. And now the name has changed. Ha. Okay. In which case, can I force the old version of Text Builder then? Because I'm expecting Text Builder to be below 1. Okay. So if I use this to say that I want to ignore this and use Text Builder, and I will want to force an older version, and let's say then that I want I was on 0.6.7.3, I think, but let's just try 0.6.10 or something. Like, I know better and I want to force... Okay. This is annoying. So let's say 0.3.4.1 then. Are you happy with this? Nope. Okay. I really don't want to spend my evening debugging versioning issues. So let's do the thing where I instead use the local version. And in the local version, let's change to the new text builder version. At this point, it would have been faster to just create the dot file manually. So it is. Okay, so I will want to say instead that text builder now, I'm gonna want a version that's at least 1 but not 2 to be up to date. And that means text. Okay, not imported here. This is probably gonna be needed in text dot build. Nope. There we go. And now this is text builder. Let's try to compile this and check that this still compiles. Oh, is it because I still have a locked version? I don't. So why can't you resolve? Oh, because I probably need a cabal update. There we go. Hello. I am fighting against the dependencies because I'm now in dependency hell. I'm trying to use my own library for graph generation. And since I've released it, the package that I'm using for text building has had an upgrade and broke everything. So I am debugging my own library to be able to then use it for the Advent of Code stuff, purely for visualization. So this is a side project and a side project and a side project. I haven't made a lot of progress on the actual Advent of Code stuff, except we started with the fun thing, which is that our graph has pointers to its parent and its children. And this is not like indirection; those are actual pointers. So it's an infinite structure that we use by using some form of like laziness recursion, where basically the graph is constructed from a hash map. Here, the graph map that is constructed as a mapping from the name of the nodes to the node, but the nodes also use the same hash map that we are building at the same time, which is neat. Okay. Does it look like... Okay, now, at the risk of making this poor computer explode, I'm gonna try to... Oh, I'm not sure this is gonna compile on the first try, actually, so maybe let's wait until this compiles. I can try to do both. Let's run 2 compilations at the same time, and let's watch this computer burn. Yeah, I still don't know what part 2 is about. I'm curious about it. I suspect it's gonna be tricky. I just don't know how tricky yet. Text builder does not export builder. What did they do to this library in 1.0? I think I'm just gonna rewrite my library to just not use text builder. Ah, it's called text builder now. Okay. I mean, it's fun to have like self-imposed rules for a project like this. So it is called text builder. So we can do a build to text builder. Okay. Let's try compiling this. Run no longer exists. This is now to text. Now the example don't compile. That makes sense. Give me 1 sec to just fix this, and I'll be with you in a sec. Is there a... Because I assume put ln to... Okay, that doesn't exist anymore. So this is going to be a import text IO qualified as t. This is going to be a t put string line of this TV. How do you say it was this time? To text. Wait, what's the difference between text and to text? Oh, it's the other way around. Okay, so for day 10, what I ended up doing was I cheated for, come on. For part 1, I did write a very simple BFS, like a very simple, basic manual BFS that does like on lists, absolutely inefficient, but it was good enough for part 1. For part 2, I used SBV, which is a library that has bindings to Z3. So I just used basically a theorem prover, a solver for this. The thing is, like, I could identify that this was a system of equations. I could see what the equations were, but the methods, such as like how is it called again? The not Euler reduction. There's a thing like this. The name I forgot. Like methods for solving systems of linear equations like this, or at least optimizing systems, or the simplex algorithm. I know those names, but it's been 20 years since I've done any math. Proof yet again that you don't need to be good at math to do any Haskell. So I used SBV to call Z3 under the hood to just use the like a theorem prover for me. So I just declared, here are my variables, here's the constraints, here's what I'm trying to optimize, and let the thing run, and it gives me the solution in 8 seconds, and that's good enough. Will be tempted to try to implement one of those like methods like simplex or some of the others, but no, I haven't written it yet. I'll probably do that off stream during the holidays. Okay, so here this is missing a dependency on. Like, I know if you know the math, I think by hand it's perfectly doable. It's just I don't know the math very well. Like, I can see the shape of the solution, but I don't know it that well myself. So I just need to add here in the example, I need to add text in the dependencies. And now the example should compile, so the library should compile. There we go. And now we can try to compile. Oh, there's a few more things. Perfect. That's because since we've upgraded GHC now for this, defined but not used. Oh yeah. Okay. Since now we're compiling with the new version of GHC, because I've upgraded my resolver, a few things are no longer required. The hashable is redundant. Redundant constraint. I think I don't want to touch this file. I'm okay with those redundant constraints. That's just my library of things. Yeah, that's just my library of functions for the intent of code. I'm okay with it having warnings for now. This is not what I want to do. And now that we are done with all of the warnings, we are back into day 11 at long last. And indeed, text builder no longer exists. So now, after all of this, this is to text. There we go. It's been a while. Took a while to get there, and this is nothing. Okay, so it's this. It is the. I'm tempted to just import my library as TD, but not always qualified, so I can use, because that way Node I use qualify. Because Node, there's going to be a bunch of things called Node. Yeah. I might need to import it qualified for this. Or maybe I import it qualified as TD, and then I import it unqualified, hiding the things I need to hide, such as Node. So now I only need to use TD for Node, everything else can be used. And here that means I can use my cute syntax where an edge is declared like this. And yeah, here I need to hide Node as well. That's been somewhat a constant of Advent of Code problems, where part one is not too complicated, but part two, the naive solution will take hours to compute. Is string maybe text? Oh yes, there's a lens operator for this that is re-exported from my library. Which one is it? It is this one. Okay. Data list unused, to my surprise, but we'll take it. Real input not used, that's to be expected. Use of head. Where is that used? Oh, in this. Okay. Yeah, that's fine. Okay, so now if this worked, since we have printed something, we should be seeing a dot file, our test input file, which is our dgraph. There we go. Which means now I can do a dot to PNG of the test input dot. And that gives me test input PNG. And now we can visualize the graph. Oh, the color didn't work. The coloring didn't work. Interesting. Oh, it's probably because I'm using the SVG colors. So I probably need to do SVG here. SVG here. No, doesn't work either. Fascinating. Do I want to spend some time debugging something that is so completely unrelated to the thing we're doing at the moment? And I think the answer is yes. Is this because fill color isn't recognized, or is it because this color name isn't recognized? This might be the latter. So let's try red here. Let's make a PNG and let's open that PNG. And no, it's not recognized. Fascinating. What is dot? Oh, I think it's because the style needs to be set to filled, otherwise it's ignored. Assuming styles equal filled. There we go. So that means I need to go back to this, and here in the library, I will say that its style is filled. There we go. Now I can recreate the PNG, and now we have the color. Okay. So that's our test graph, and we can see indeed that there's no cycles. I'm curious to see what the actual real input looks like as a graph. Took a while to get there with the mishap with my own library, which was kind of frustrating. But now let's have a look at what... Yeah, some people do some incredible visualizations. I try not to look at the Reddit too much to avoid spoils, but yeah, when I have a glance, it's pretty impressive. You can't see this command line. It was this. Okay. That's our graph for the real input. Okay, that's not too bad. This confirms at a glance what I was suspecting, which is that we have no cycles. Which is convenient. Okay. Well, I'll spend some time off stream making a new version of my library that uses the new version of Text Builder, so that other people who try to do the same thing as me don't get stuck with this old thing. In the meantime, let's actually solve the advent of code, shall we? So, part one, what we are trying to do is count the different paths that go from you to out. And for this, I'm going to start with from the exit and count the number of paths that go from it. And since, can I assume there's no cycles? I think I have to assume there's no cycles, otherwise it makes no sense, right? Because if there was a cycle from A, B, C, and then from A to out, A, B, C, A out, and A, B, C, A, B, C, A out would be two different paths that would be valid. So I think there cannot be cycles by definition, otherwise this thing would make no sense. So I think here, given a graph, we are just gonna go and visit the graph start, which is a node. And when we visit a node, if the name, actually, no, the start, we're going to start with the exit, actually. If the node that we're currently visiting, what's the name of the accessor? It's node name. If the node name is the start node, start name, then we return 1. Otherwise, we are not on the start node yet. We return a sum of map visit of the edges in, so the parents, which is data in. I think that's... The only thing is we might want to cache this. Is the thing. To avoid, because here we're going to traverse, this should work, but we're going to traverse a few things. Like if I do this, let's open this, we're going to do this and like, oh, this one, how many things arrive? So it's going to be one for each of those. If we don't cache them, when I go from this one to this one, I'm going to ask this one. And then when I'm back, I'm going to ask this one to give me this one. And then it's going to ask this one again. And we're going to recompute something that's not needed to compute. So we should memorize this. We should keep a cache. And the easiest way to do this would be to use a statement add again. So this would be an eval flip, eval state, with an empty hash map. And therefore visit becomes a monadic function. This remains the same, except this is not pure 1. Except I'm going to write it slightly differently. I'm going to write it as an if node name equals this thing. Then we return pure 1. And otherwise, this could be a multiset, I suppose. But here I am more worried about, if I open this again, I am more worried about like it seems that it is layered, but I don't want to make that assumption, which means I don't know necessarily that like I'm moving from one to the next. I suppose I could do it as a like hash map of count, but I prefer doing I think a memoized version. Because if I were to do it as like because like here imagine that there was a edge that went from this node to this one here. This would not be a cycle, but I think the multi-set approach would be a bit complicated to make work in this case. I think the memoization is going to be slightly simpler. So I'm going to use it instead. So what do we do in the case where we are not at the start? Maybe I actually want to do... No, it's fine. So here we're going to do I'm in the state monad, so I can do a get s with a function which is a lookup of our node name. And it gives me two things. If it gives me just... Something is wrong with my syntax somewhere. If it gives me just a result, that's our result. And otherwise, if it doesn't tell me anything, it means I have not visited this node yet. In which case, I compute my result. Something is wrong. That's fine, we'll fix it. My result will be a sum of traverse with visit of the parent. I put the result in the state, so modify my state to do an insert of node name and the value, the result. I'm almost tempted to make it as a memoiz otherwise. I think it's fine. It's fine like this. Like this is a bit manual. I could write it as a function that takes another function, like a memoiz that takes the function and does the caching for me, basically, rather than doing this manually in my visit function to make it to like make it very clear. But I think it's fine like this. And at the end here, we return our result. Okay. Yeah, okay. New version of GHC have a warning for head and tail. So let's rewrite the main to remove those warnings, I suppose. I'm gonna actually do... Can I do this and use a monad fail thing? Will it be happy if I do that? Do I have a usage? I don't have a usage. No, I have print usage and die. Perfect. Print usage and die. Or rather, if I have folder and then days, do that. And otherwise, print usage and die. There we go. That should remove the warning. Perfect. Now let's go back to day 11 and let's uncomment part 1. I could probably remove the write file there, but It's fine to have it. I should also remove this print. I get 5 for the test input. There we go. That looks correct. For the real input, I get 571. That's the right answer. Okay. Let's see what part 2 is about. Okay, so the names are not arbitrary. Interesting. So here there's an FFT somewhere. Actually, I'm gonna use the fact special colors is gonna be a map from list, and to start name, I'm gonna associate pale green. To exit name, I'm gonna associate plum. And to FFT, okay, SVR, DAC, and FFT. What do we want to use for the color of those? They are special SVG colors. Let's make them some kind of blue, I guess. A medium turquoise. That's not exactly blue. That will do the trick just fine. And let's do that for all the special nodes, which is FFT, server, and DAC. Okay. And we can rewrite this as case lookup of the name in the special colors of nothing, do nothing. Here I could use a when m, when just, I mean, if I had the library extra in scope, which I might have actually. Extra is there, so I could use control monad extra. I could use a when just, there we go. There's always a tension. I'm trying to keep the agent of code somewhat accessible, but there's always a tension of like, do I actually use fun libraries or do I not? Here, I think a when just of this lookup that takes the color. When there is a special color for that name, what do? We do its style filled and its fill color, the color. Now we're gonna rewrite the graph. And I forgot to do block here. There we go. It is the thing called its is a alias for my library that points to the latest created ID. So I create a node and its style is, its fill color is. Here I could do instead attribute node ID style equals, but I have this its thing to just be able to do its style, its fill color. It is somewhat inspired by the fact that GHC has a thing called it, which is like if you do a computation, a map show on 1, 2, 3 something, you can do it, and it gives you the previous result. So it, the last thing, is the node ID, and therefore it is the attributes of that thing. So let's recreate this, and let's have a look at what it looks like. Aha. Did it not do anything? Oh, did I misread the thing and there is no... Wait. Either there's a bug in this again, or there isn't any DAC and FFT in this real input. That feels incorrect, right? There should be one. Different start node. I think you're correct. Thank you. I think you are correct. That's exactly the problem. That is exactly the problem. And in fact, I should probably... Maybe I don't need to keep track of the start node. I don't know. For now, maybe this thing is incorrect then. So let's change something. Let's change this render to instead, I'm not going to visit gstart. This is going to be instead a this is going to be a traverse visit of the graph map. So I make sure to traverse every... Yeah, I'm solving recursively. Let me just have... I'm doing part 1 for now. I haven't tried to think about part 2. But now I do this. Let's visit all the nodes at least once. And let's see what the full graph looks like now. Okay. That explains. So now I do see our DAC here. U is... Okay, so that's why U is part 1. Part 1 is only this thing, which is fairly straightforward. And now we have this nightmare. At a glance, we still don't seem to have cycles in the graph, which is nice. Okay. I should leave this open in the background. It doesn't matter. Okay. So we are trying to find... Isn't that just a matter of... Because I'm thinking, as far as I know, there is no cycle in the graph, right? Like, this is not an assumption I want to rely on, but as far as I can tell, that graph doesn't have cycles. What that means is, as far as I can tell, there's no way for something like, if this DAC is after FFT, there is no path that's going to go through FFT and then through DAC, right? The other way around. Like, there's no way that this would go back after this if there's no cycle. Which means if there's no cycle, then the solution is this is the number of paths from the start to FFT multiplied by the number of paths from FFT to DAC multiplied by the number of paths from DAC to out, I think. Which means traversing the graph 3 times, but that's not the end of the world. But that's assuming that there is no cycle in the graph, which I think there isn't, because again, otherwise, if there were cycles, the question of counting the number of paths would make no sense. Okay, so let's rewrite this, I think. I have an idea. Let's see if it works. First, I'm going to rewrite part 1 to make use of a function. And this function is going to be count paths that will take our graph, of course, but the name of the start node and the name of the end node. So count path is going to be basically a very similar thing to what we're doing here. This is going to be a flip eval state something. So we are going to have we have our graph here as an argument. We have the start name. Start name is already something that exists. From name to name. We're going to do this. We're going to do this state monad to keep the cache. And we're going to use visit on looking at the graph map, which is called gnodes, at starting at the destination. And where visit is going to be basically this. I'm tempted to try to do this thing. I'm going to memoize visit. And memoize is going to be a function. If I have a function from A to B, and I have an A, and I happen to be in some kind of monad state in which I am carrying a hash map from A to B as my state, then I can return. Well, I suppose this is more of an A to MB, actually. Well, no, it can be an A to B. And this is now a function from A to MB. And so memos of a given function f and an argument a is get a lookup of the argument. If it's already found, return just that, and we don't call the underlying function. Otherwise, we compute the result. It's not gonna work. It's not gonna work because here visit would need to be something. I would need to use a fixed point. It's gonna be annoying. So let's just make it here a function from A to MB. So here, this result is just f but it means it's gonna need to know. It's a bit annoying. Okay, let's not bother with this. Let's just keep it the way it is. So here I visit, start by the destination, and I will count the path. When he's gonna be instead from name. So if I have reached my destination, I will. And then otherwise, I do this lookup. Okay, that should be fine. The only thing is, we could want to try to detect, like I could try to detect ahead of time to know like some kind of ordering of a node and know, like I could make a map from a name to all of the names, like a name to all of the set of the names, and therefore I could check, is this node a parent of, and therefore I could know, whoops, I have already reached a node that is above the one I'm targeting, which means that would avoid traversing the entire graph for nothing, basically. But we'll do that if that's required for optimization. For now, I don't think it is. So this is what counting the paths is. Let's rewrite this function now as being, for a graph G, this is count paths of G, and I'm going from U to out. Well, I'm always going, no, it's fine. And so let's first check that this still works, and I haven't broken anything. I have broken something. This is missing the result, which is an int. So that seems to be still working, perfect. And now we can do part 2 as being oh yeah, given that this is fast already, I think the optimization isn't really required. What I need here is to count. So I don't know which order I might visit them. But again, since there's no cycle, the order is guaranteed to be. So this result will be the sum. Well, no, not the sum. It will be the product of max 1, so that if we don't find paths, then the value is 0. And we are going to count the paths from DAC, from server to DAC. Oh wait, I can't do that. I need to figure out the order first. I need to figure out the order. So that means, because there's one of the two, if I do count paths DAC FFT, one of those two will give me 0, basically. I guess I could therefore do the sum of both cases. That feels... Yeah, we might want to do the optimization afterwards. This might work, but we'll want to optimize. So let's do that. There is go with FFT and DAC plus go DAC FFT. So I'm counting both possibilities, and one of those will be 0. And go with node 1, node 2 is going to be the product of count paths of G from out to node 2, count paths in G from node 2 to node... Well, it's the other way around. It's from 2. So node 2 to out, node 1 to node 2, and count paths from in G from the starting point, which is server, is it again? SVR, not SRV. To node 1. Good night. Thank you for tuning in. So hopefully this will give me the correct value for one of them, and I'm just going to reorder them, and it's going to give me 0 for the other one. Okay, that should be it. See ya. Okay. Oh. Oh, of course. Here I am running the part 2 on this example, which is the example for part 1 and doesn't contain any of the nodes that we need. So let's use this version. So this is example 1. Let's have an example 2. And here, the reason why this is crashing is when I am doing the count paths here, I am doing a lookup, a partial lookup that crashes, that panics if it fails in my list of nodes because I assume the name exists, which isn't the case here. So let's rewrite this. Why don't you? There we go. So there's going to be test input 1, test input 2. And I am actually going to make a new render of it for the second version, just to see what it looks like. And this is test input 1, test input 2, which means here I'm going to need dot of the test input. Aha, it doesn't compile yet, that's why. Example 1, example 2. What are you on about? It's 0 bytes long. That seems to be a problem. Because test input to the dot is empty. Huh. What happened there? This is before I... Huh. Line 99. That means there's no exit name in this. They do put out here. What does that mean? Oh, is it this no start name? Aha. In this input, there is no U. So this second input fails to pass, which means I think I don't need to do any of this. I think the graph is just the hash map. I don't need to keep track of those other things. And therefore, here I am returning not where are you? Pass of the thing, pass input there. I am returning purely the graph map. I don't do those lookups. There we go. That should be better. Which makes a few things easier. Now it means I don't have to unpack the graph, I can just give it like this, and this is just graph. So G nodes, there we go. This is just the graph, which means I can rewrite this as in point 3 style, and I just don't need to give the argument here. Perfect. What's left to fix? Render. Okay, this one I just fixed there. Perfect. This binding shadows the existing binding in text.render. Okay. Let's hide graph. Okay, it runs, it gives me something. If I look at okay, so here it says, it should say only what should it say? There's only 2 paths from SVR to out, visiting both of them. And that would be from here, we need to go there, and then we need to go there. And it's either we do go through H or through G. And we do find 2 indeed. Perfect. So we have our response, our value here. Let's see if it's correct. That's the right answer. First try again. I'll take it. Now, if I wanted to make an optimization there, the big thing I'd like to change is if I recreate the real input graph, ah, nice. Yeah, I suppose just doing a full DFS and counting, yeah, that would work as well, I think. So the thing is, I would like to, one optimization I'm thinking of is I could very trivially make a topological sort of this graph, and that would allow me to say, basically, to figure out ahead of time, what is the parent, like, is this node below this one or above this one, basically? And that would mean I could not only make things easier, like for instance, if I'm looking for a path from this one to this one, if I reach this node here, I don't need to continue because I know it is above my target, basically. And that would avoid searching for nothing, because here a lot of those, if I'm searching from the path from this one, from out to this one, I'm gonna still traverse the entire graph. And that would also avoid having to do this thing where I do the sum of the 2 possibilities and knowing that one of them is gonna give me 0. So that would be a nice optimization. How do I do a topological sort? Well, I would need to know the root for sure is the only thing. And here I have to make an assumption about the root of the graph. But if I know for sure that the root of a graph is... Because this works pretty fast, right? This is, including the time of generating the graph and everything, this runs in a second. Like when it runs, it's immediate, basically. The 1 second is the warm-up. So I think I'm okay with this. It feels... It would be nice, I think, to avoid having to do both like this, but it feels like this. I'm counting the path from the start to the node, then node 1 and 2, and I do the product. I think this is good enough as it is. Okay. Well, that means that's all for day 11. There is only one to go. Because this year is a short year. I might not be able to stream tomorrow, which means I'll do it early next week. I won't be able to stream a lot next week either because holidays approaching and everything. But yeah, this has been a journey, and yeah, I agree. I think today was surprisingly easy, especially compared to day 9 and 10 that were quite difficult. Although I suppose easy is relative. Graph traversal is something I'm extremely familiar with, and like recursion in Haskell is kind of like my bread and butter. So I'm very familiar with this. I am a lot less familiar with the kind of geometric nonsense we were doing in day 9, and I don't know any of the math we were doing yesterday, which is why yesterday I was using the solver, the theorem prover, just because yeah, that's not something I'm familiar with. So this day felt easy, but that's because that just happens to be the thing I'm familiar with. We spent more time actually fixing my yeah, I was expecting more of a trick there as well. Yeah, we spent more time fixing my small library than we actually spent time um we actually spent time changing this. The thing is I'm gonna have to figure out, this is gonna have to be a new release of my library. Does the fact that I had to change a dependency to a new version, to a new major bound, I guess it breaks everything, so it's gonna have to be a new major release of my library, I suppose. Wait, I'm on dev. What's the difference with main? Fix round typos, okay. Because yeah, I suppose this could be. This is probably gonna be a. Wait, why am I doing a render ATB to text in there? That feels incorrect. Oh, no, because I'm creating a list of attributes. So those have to be text. Yeah, no, that makes sense. Okay. Yeah, I'll probably do that outside of the stream, but I think I'm just going to have to do a new major release just for the fact that my dependency has changed so that it's compatible with current version on Stackage, I suppose. Which means I'm going to have to figure out. It's going to probably just become a 2.0, I guess. Just because of this text builder thing. Because currently the version on Stackage is now the 1.0. So yeah, I should probably do that. But I will do that off stream. I think releasing a new Haskell library is gonna be like, if I were certain about the steps to do there and like the checks I want to do, I could do it on stream. But there are a few things I don't remember all the steps, and there are probably more checks that I want to do, so I'll do that off stream. Which means it's 10:30. It's not super late. I could try to do some work on the compiler, I guess. I still haven't done any of the editing of the videos, so none of the Advent of Code stuff is on YouTube yet. I should really do that. But yeah, I guess I can make a tiny bit of work on the compiler, like for an hour or something.